Good morning, students, and welcome to our School from Home Wednesday. So we're going to start our lesson today with our Do Now, where we're going to carefully respond to a prompt about simplifying our schoolwork routine. Why is that important? Our objective will be to continue our work with square roots. Our essential question is, how can I calculate a square root, and how can I simplify square roots by factoring? As we watch our video today, we will complete the one page on square roots, and we have some important lesson notes. So please have some notebook paper ready so you can copy those lesson notes. So we have an exit ticket where we want to answer the question, what does it mean to factor? And remember to show your work to the teacher during class. If you have a problem with your camera, take a picture and send it to me by email. That's how you get credit for the class. For homework, if you have not finished the lesson, please complete it. And remember, we want your camera on at least during our discussion in the beginning and at the end when you show your work. Respond when your name is called at the beginning, the middle, and the end of the period. And remember, this is the most important thing. This is how you get credit. You have to show Mrs. Gold your work. And if you have a problem, then send a picture to my email. So let's get started with our lesson. We'll begin. Let's not forget, Friday is Spirit Day. It's Whaler Pride Day. Wear your green and gold to show your Whaler pride. Okay, let's get started with our Do Now. We've got our New Year's clocks again. So we're thinking about something called an intention, and an intention is a thought that guides us. And today, our goal, our theme for the entire day and all of our Do Nows is to be guided by simplicity. And the question is, what can I do to simplify my schoolwork routine? Are mental and physical clutter impacting my school success? Sometimes you really need to physically clean your area where you do your schoolwork. If you've got too much clutter around you, it can really draw your attention away from the lesson. So even right now, if you look around you, I'd like you to look at your desk or your bed or wherever you're sitting and clear everything off except for your math stuff. Give yourself the gift of full focus when you do your math lesson. Anything else will just distract you. Take the phone, turn it upside down, put it on a table across the room. Give yourself mental and physical clean place to work from. That's a gift you deserve. So think about this honestly. These do now questions are hard questions. We have to ask ourselves things that maybe we don't want to answer right now. But I'd like you to do that right here. Give me a sentence or two about your thoughts, and we'll get back to our exit ticket. So let's begin our lesson on square roots. So as we begin today, I want to move to our notes page, and let's talk about these square roots. A square root asks the question, let's get my highlighter ready. A square root asks the question, what number times itself equals the number inside the radical sign? Okay, and this is the radical sign right here. So if I have this problem, this example, with a radical sign with a 49 inside, that problem asks, what number times itself equals 49? So here's what we want to think about as we try to solve this problem. We want to think about your multiplication tables, and this is another reason why you should have those multiplication tables really memorized, okay? So if you think to yourself, well, I know that 7 times 7 equals 49. So 7 is a number times itself that equals 49. So if 7 times 7 equals 49, then the square root of 49 equals 7. So that's square roots. Now, I'm going to talk about factoring a square root. To factor means to find numbers that multiply out to equal the number inside the radicand. To factor, we want to find perfect squares in particular. So let's explain how that works. So to factor a square root, I must determine if there is a perfect square that can be multiplied by another number to get the number inside the radical symbol. So let's think about what that means. Well, first of all, what are the perfect squares? So we want to think about those. So here's the perfect squares. I'm going to write them in this orange. 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. So 4 is a perfect square. I can't believe I just wrote 2. 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. 5 times 5 is 25, so 25 is a perfect square. 6 times 6 is 36, so 36 is a perfect square. 7 times 7 is 49, so 49 is a perfect square. 8 times 8 is 64, so 64 is a perfect square. 9 times 9 is 81, so 81 is a perfect square. And 10 times 10 is 100, so 100 is a perfect square. So the first 10 perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Now, they go on, as you can imagine, to infinity. They can get really big. So sometimes a calculator can help you. That doesn't excuse not knowing your multiplication, your basic facts, though. So let's try to factor the square root of 90. Sorry about that. Let's get back to our page. Little glitch. Okay, let's factor that square root of 90. So here's our example. We're going to factor the square root of 90. So what do I think? How does my thinking go as I go about this task of factoring the square root of 90? Well, if I think about the number 90, what are the factors or the numbers that I can multiply together to get to 90? There are a couple that work for us. I can multiply 9 times 10 and get to 90. I can multiply 45 times 2, and that gets me to 90. I can multiply 5 times 18. All of those equal 90. But as I look at these numbers, the 9, the 10, the 45, the 2, the 5, the 18, okay, is there a perfect square among that group of numbers? Well, there is. 9 is a perfect square because 9 is 3 times 3. So 9 is a perfect square. Because 9 is a perfect square, I am going to define 90 as 9 times 10. So I've asked, are there any perfect squares? Yes. 9 is a perfect square. So if there is a perfect square, then this is the important part, the square root of the perfect square comes out of the radical. Let's say that again. The square root of the perfect square comes out of the radical. Okay, so the 9 doesn't come out. The square root of 9 comes out. What is the square root of 9? The square root of 9 is 3 because 3 times 3 is 9. So let's go through the steps. Okay, first step, I figure out what are the factors of 90. And I figured out that 9 times 10 are factors of 90, and 9 is a perfect square. So because I have a perfect square, then the square root of 9 comes out. So the remaining numbers stay inside the radical. If it's not a perfect square, it doesn't come out. only the square root of the perfect square comes out. So if I have 90, if I'm asked what is the square root of 90, and I determine that 9 times 10 is the square root of 90, and 9 is a perfect square, then that 9, the square root of that 9 comes out of the radical. And the square root of 9 is 3. So 3 comes out, and 10 stays inside. So this is our final answer. So let's do some practice. So first I'm asked to calculate each square root. Now, I've said this before, you want to memorize at least the first 10 squares. And if you really want to make your life easier, especially as you get into algebra, you want to memorize the first 20 perfect squares. And if you were to memorize the first 20 perfect squares, you would know that 169 is a perfect square. But if you didn't know that by heart, you could use your calculator to help you, and you could just try some numbers. Well, I know 10 times 10 is 100, so 10 is too small. So what is 11 times 11? 11 times 11 equals 121. Too small. How about 12 times 12? 12 times 12, I can use my calculator, equals 144. Still too small. Well, what happens if I multiply 13 times 13? Well, if I do, I find that 13 times 13 equals 169, which is just right. So therefore, the square root of 169 equals 13. Now with number 2, we have a fraction. But I do see that 25 is a perfect square and 81 is a perfect square. So remember, perfect squares, if we have those inside the radical, then the square root of the perfect square comes out. The square root of a perfect square comes out. That's what you have to remember. Well, the square root of 25 is 5. The square root of 81 is 9, because 5 times 5 is 25. 9 times 9 is 81. So that's our final answer. We don't have a radicand left. If everything comes out, there's no radical symbol left. Now, sometimes we have to approximate perfect squares. And when we approximate, we use the squiggly equal symbol. That means approximately. So let's think about this. How can we approximate the square root of 61? Well, I know that the square root of 49 is 7. I know that 7 times 7 is 49, and that's too small. I know that 8 times 8 is 64, and that's too big. But which one of these is closer to 61? Well, 64 is pretty close. So I can say that the square root of 61 is about 8. And the same is true of 180. So I can try. I know that 12 times 12 equals 144. So 180 is not a perfect square. I'm not going to get it exactly right. I know that 13 times 13 equals 169. I know that 14 times 14 equals 196. So I think the closest thing I've got is the 13 times 13. So I'm going to say it's about 13. Now, in the next group of 4, we're asked to simplify by factoring out perfect squares. Okay, so now we have to look for those perfect squares. So let's think, how can I make 48? Well, and again, use your calculator, do some division, see what you can figure out. I know that I can make 48 with 12 times 4, but there's no perfect squares. So 12 times 4 isn't going to work for me. I know that 2 times 24 also equals 48, but that's not going to work for me because I don't have any perfect squares. But I also know that 16 times 3 equals 48. Bingo, I've got a perfect square right there. So the square root of 48 can be thought of as 16 times the 3, the square root of 16 times 3. And 16 is going to come out, the square root of 16 will come out. So the square root of 16 is 4 because 4 times 4 equals 16. So 4 comes out, 3 stays inside, and that's the final answer. So number 6, I need perfect squares. I start to look at the larger numbers, okay? I start to look at 10 times 10 is 100 is a perfect square. 144 is a perfect square. 169 is a perfect square. And I just grab my calculator and I'm going to try to divide 720 by perfect squares. To see if there's anything that evenly divides with no decimals, no fractions, that evenly divides into 720. And as I do that, I find out that 144 times 5 equals 720. So we can say that the square root of 720 equals the square root of 144 times 5. Now we can pull out the square root of the perfect square. The square root of 144 is 12, so 12 times the square root of 5 is the simplified factoring of the square root of 720. I think number 7 is a little bit easier because we immediately see that we can get to 500 by multiplying 100 times 5. So 500 equals 100 times 5, and 100 is a perfect square. So the square root of 500 will equal the square root of 100 times 5. The square root of 100 comes out. What's the square root of 100? 10, because 10 times 10 equals 100. And then 5 stays inside, and that's your final answer. And now the square root of 75. I know that 75 is, let's see, there's a couple ways to get to 75. I know that 75 is 5 times 15. I also know that it's 3 times 25. Well, 25 is a perfect square, so let's use that. So the square root of 75 equals, I'm going to change my color, the square root of 25 times 3. The square root of 25 comes out. The square root of 25 is 5 because 5 times 5 equals 25. 3 stays inside, and that's our final answer. Okay, now here's the thing with x squared. We did talk about exponents. So the exponent of 2 here means that x times x equals 400. And I know we haven't used variables really in our class yet, but I want you to think of a variable as kind of asking the question. And if the variable is the same letter, then the number that it substitutes for has to be the same number. So all we're asking here is what number times what number equals 400? And if you haven't memorized your squares, your perfect squares, you can take your calculator and start dividing 400. Divide 400 by 10. Well, 10 times 40. Or what else can you divide 400 from? We're looking for numbers that divide into it perfectly. And just take your calculator and divide 400 by different numbers. And as you do that, when you get to 20, you'll notice that 20 times 20 equals 400, right? So if 20 times 20 equals 400, then x must equal 20. But let's remember one thing. Square roots can be positive or negative because when we multiply a negative times a negative, we also get a positive. So we can say 20 times 20 equals 400. We can also say negative 20 times negative 20 equals 400. And for that reason, we say that x is plus or minus 20. And that's your final answer. So number 10, 169 is another perfect square. We actually talked about it in one of the other problems, but if you don't remember what it is, use your calculator. What number, when multiplied by itself, equals 169? And as you use your calculator and memorize your perfect squares, you'll see that 13 times 13 equals 169. But also, negative 13 times negative 13 equals 169. So x in this case can be positive or negative 13. And let's look at number 11, x squared equals 256. So if x squared equals 256, something times something equals 256. And what is that number? So you grab your calculator and you start trying different numbers. You'll see that 16 times 16 equals 256, which means negative 16 times negative 16 will also equal 256. So x will equal plus or minus 16. And then number 12, we'll go through the same process. We'll grab our calculator and we'll look for those numbers that multiply by themselves to get to 324. And what you'll find is that 18 times 18 equals 324, but also negative 18 times negative 18 will also equal 324. So therefore, our x can equal positive or negative 18. So let's go back to our exit ticket. To factor means to find numbers that multiply to the number being factors. Now, there's a second piece to this. If you are factoring a square, excuse me. So if you're factoring a number in a radical, look for perfect squares. And then you're going to pull those perfect squares out of the radical. So let's use the example of, let's factor the square root of 200. Well, I know that the square root of 200, I can get to 200 by multiplying 100 times 2, and 100 is a perfect square. So I will pull out the square root of 100, which is 10. I will leave the 2 inside the radical, and I factored the square root of 200. So I know there's a lot of new material here. You might want to watch this video 2 times, but remember, clear your desk, clear your bed wherever you're working. Keep it simple. Focus on one thing only. This is a gift that you give yourself. Honor yourself with simplicity and focus. And with practice, you'll be great.